Hey, hey, hey. All right, let's go ahead and get started. Grab pencil, pen. You know the drill by now. Okay, so this PowerPoint is the first one for evolution. And evolution is one of my favorite units, especially for the spring semester. Okay, so before we start, let me tell you a little story. So you don't have to write anything down, just listen to my story. Okay, in 1920, that's not important, the year isn't, a man by the name of Alexander Fleming had petri dishes, and these petri dishes, he was growing staph bacteria. And so when I say staph, I mean like if someone has a staph infection, right? You've probably heard of that before. And so here's the bacteria streaked on a petri dish. Okay, and it's like a bacteria, right? Okay, so he was trying to find something to kill the staph. And so he would sprinkle something on it, probably he was trying like different salts and different chemicals. And he would wait, and the next day, if the staph was still on the petri dish, he'd throw it away. Well, one day he was throwing out old plates, and he was thinking, man, it didn't work. Man, it didn't work. And he came to a plate that had some mold on it. So let me draw some mold right there. And around the mold, there was an area where no bacteria had grown. So if you look right there, there was, you can kind of see it perfectly. Where the mold was, there was no bacteria. And so he took the mold, and the name of the mold was called Penicillium notatum. That was the scientific name of the mold. And he discovered that this mold released a chemical that killed bacteria, a natural chemical. And so from that mold, Alexander Fleming made the very first antibiotic in 1920. And you've probably already guessed what's the name of that antibiotic. Well, it's penicillin. And so, penicillin's made from mold. And that's not the point to the story. Okay, so in 1920... I'm telling you, textbooks say it, everybody agrees that in 1920, penicillin killed staph. Well, roughly 20 years later, people were going to the doctor with a staph infection, getting penicillin, and it wasn't working. Penicillin had been prescribed against bacteria. It was like the best thing ever. Well, it didn't work anymore after, 20 or 30 years. Penicillin didn't kill staph anymore. Well, so what happened? Penicillin, the antibiotic, didn't change. What happened was that staph, the bacteria, changed. Right? It didn't become immune to the antibiotic. No, that's not the answer. But something inside the staph changed, and now staph wasn't killed by penicillin anymore. And then they made another drug, just to finish the story out, called methicillin. And methicillin worked really good for 20 or 30 years. And now methicillin doesn't kill staph anymore. What happened? Staph changed. Again, staph changed. And so, what is that? One thing that I think is important to realize is, did staph change intentionally? No. It changed by freak accident, by coincidence. It changed totally unintentional. And so to think about, staph changed and now it's not killed by penicillin anymore. Is that a sinful thing to think about? No, not at all. It just happened. Staph changed. And so, actually now, staph infections have changed so much that there's actually a different type of staph. Staph has changed so much that now they call it Enterococcus instead of Staphylococcus. So wait, what I'm saying is that this bacteria changed so much, they gave it a different name. That's what evolution is. Evolution is, so you want to write this at the top of your paper, evolution is when organisms change, they change. That's it. They adapt. Hey, staff adapted to penicillin and said, no more killing me. And it doesn't happen over a period of one day. That would be black magic. No, it's not a period of one day. It's over a period of time. So evolution is change. We're going to add a little word right there, over time. It takes years for it to change. Okay, so let's go back to the PowerPoint now. And we're starting out with a man by the name of Charles Darwin. He wrote a book called The Origin of Species by Means of Natural Selection. Okay, story time again. Charles Darwin was a man, and he was going to be a preacher. And I won't talk too much about him because he's in tomorrow's video too. But he was a man that was going to be a preacher, and he decided that he was going to take a voyage around the world. And in his voyage, he studied how these animals had different beaks, and different turtles had different necks, and insects had different numbers of legs and different types of tentacles. And he said, I think that natural selection occurred, and so he actually termed the word natural selection, in that nature gets to decide who lives and who dies. If you're a deer and you're really fat, then you get to survive if you live in the cold weather. And if you're a deer and you're really skinny and you live in Alabama, you're going to die because you're going to die from a heat stroke. And so nature, environmental factors get to decide who lives and who dies. Okay, because there are similarities and there are differences. So let's talk about birds for a second. Birds all have legs and feathers and wings, and they all have two eyes, and so they have lots of similarities. Scales on their feet, but there's different types of beaks. There's beaks that are best for breaking open seeds, and there's beaks that are best for drilling holes and getting worms, and then there's pelican beaks. So there's all different kinds of beaks, and so write that in. Birds have similarities, but birds have different beaks too. Okay. They also adapt to their environment. So where it's cold, they change. Where it's hot, they change. And then the geographic distribution is around the world. And so squirrels here in Alabama are different than squirrels that live in New York or squirrels that live in North Carolina because it's colder there. And so Darwin's theory of natural selection, it says, natural selection and competition are major driving forces. Wait, competition? We know all about competition from ecology. So natural selection and competing are all driving forces to the evolution of species over time. Nature decides what species are able to survive and reproduce. Those within the environment. So those with favorable traits for that environment survive and reproduce. And those with unfavorable traits, like if you're fat and you live in Alabama and you're a deer, die. And so nature gets to survive. And write in based off weather, the amount of rain, things like that. Okay, so just a little history on evolution. So Plato believed that there were two distinctly different worlds exist based upon the gods of Olympus and Earth. So underline for me, gods of Olympus and Earth. There exists a real and perfect world, the world of gods. The other that exists is imperfect, like where you live and where there's heaven. So the heaven and an earth. And that was, before Christ, so 347 before Christ. Aristotle was next. He developed scala naturae. It means the scale of nature. Aristotle believed that each species has its own, like you're more organized and complex than a monkey, who's more organized and complex than a dog, who's more organized and complex than a cat. So there's like a scale of complexities. And so like a rung of ladder, the species position is permanent and perfect. So that a God created these animals and they haven't changed since. They haven't evolved at all. They haven't changed since. And that's not true. Animals have changed. We know that. Bacteria, that's why I started with that story, have changed. We can see it in our lifetime, that bacteria have changed. Now, I'm not saying that a God didn't create the animals. I'm saying that since the animals were put on earth, they have changed. So, he wasn't right with the permanent and perfect. I mean, the average size of humans has gotten bigger. So, I mean, yeah, we've changed. Okay, Carolus Linnaeus came up with this organization system. He did taxonomy. It's the science of species classification. His system uses, circle the word binomial nomenclature. That means everything has two names. Example, Homo sapiens. Example, Staphylococcus aureus. Example, from the beginning story, Penicillium notatum. He came up with all the different names. And he came up with everything needed two names. And your name comes from your genus and your species. So our genus is Homo, and our species is sapiens. Okay, so if you look at this picture here, that's just showing you. And the correct way to write it is to capitalize one letter, lowercase the other, and then italicize or underline it all. So if you were writing this, the correct way to write it would be to underline it. Okay, domain. That's either you're a eukaryote or a prokaryote. And so domain, write that in beside domain. Eukaryote, which is a cell with a nucleus, or a prokaryote. Okay, so tell me, the only thing that's a prokaryote is a what? It's a bacteria, right? So you know that. Okay, so you got domain, kingdom. There's 6 different kingdoms, and so write that in, 6 different kingdoms. And these kingdoms, there's animal, plant, fungi, protist, eubacteria, and archaebacteria. And that's the kingdoms are composed of, the kingdoms, those are like, for example, in order to go in my kitchen cabinets, you have to be a kitchen utensil, like a plate or a bowl or a cup. Like my tennis shoes would never go into my kitchen because they're not in that kingdom. So a plant would never go into the animal kingdom. So each kingdom has certain characteristics that make it its kingdom. Okay, so animals are all heterotrophs. Plants are all autotrophs. Okay, and then there's the phylums, and we have the phylum Chordata because we have a backbone. And then there's classes, and we are the class Mammalia because we produce breast milk and have hair and all the things that mammals do. And then order, family, and then the genus and species is what makes up the scientific name. So that's your specific scientific name. Okay, so a sentence is dominating King Phillips came over for green salad. Okay, so I need you, not the sentence, but somehow I need you to be able to memorize this before you come to class tomorrow. There's domain, kingdom, phylum, class, order, family, genus, species. So somehow you got to remember that. And you want to know that this is the most specific. These down here. And kingdom is the most inclusive, so the broadest, not specific, right? Like we're all alive, animals and plants, so not very specific. So kingdom, phylum, class, order, family, genus, and species. And that's what I'm going to ask you tomorrow when you get into class. Can you say that? So you need, when you turn your video off, you want to make sure that you can say those. All right, I hope this was helpful.